All right, Algebra 3, Lesson 36. This starts in your book on page 256. Talks about angles greater than 360, so we can take a coordinate plane, start at the initial side, and go around more than one complete time. Okay. Sums of trigonomic functions, so we'll talk about adding trigonomic functions together. And then finally, everybody's favorite, which is the boat in the water problems. So we'll try to get through this as much as we can. Obviously, it's pretty well broken up. This first part here, we're going to talk about angles greater than 360. It's going to involve looking at coterminal angles. The next part is sums of the trigonomic functions. Basically, this is what we've done before. The only thing that you're noticing different here is that they're giving it to us in radians instead of degrees. So if you want to understand what we're doing there, go ahead and convert over to degrees and then plot it. Some of these will be in different quadrants than what we're used to seeing, though, so it is going to get more complex. And finally, boat in the water questions involve a very specific formula that we're going to follow through every time. So it's really more a matter of understanding and remembering procedure. If you understand and remember the procedure, you'll be fine. We'll go from there. So number one, name the angle in standard position that is coterminal. The term coterminal means comes to the exact same position or point on the graph. So there's an infinite number of angles that are coterminal with any other given angle because we have an infinite number of times that we could keep going around and around and around and around and around our coordinate plane, right? Does that make sense? Right? I could draw a coordinate plane, start at the initial side, and if started here, right, I could go around as many times as I want. Does that make sense? Okay. So yeah. I'm just look deep into the coordinate plane. Okay. All right. All right. So we want to name the angle in standard position as coterminal with negative 478 degrees. So let's talk about the first thing we notice about this number. What's the first thing you notice in it? It should be the first thing you read. Negative. Okay, so starting from here, which direction am I going to go? I'm going to go around, but I'm going to go around no matter which direction I go. Which clockwise? Okay, clockwise. So I'm going around 478 degrees. So this right here would represent 360, correct? All right. So I need to keep going. So a really good way to look at this, that negative only tells me which direction I'm going. All right. So don't get super duper caught up in the negative portion of it. What I'm going to do is take 478 and do what? I'm going to subtract 360 to find out how many more degrees I need to keep going that direction. All right, 8. Oh, 7 minus 6 is 1. 118 degrees. All right, well, this would be another 90 degrees, right? So I'm going to keep going. Maybe the better way to look at that at this point where I'm looking at 118 is I know that back to that point would be another 180 degrees. So I could take 180 and minus 118 to find out how far from 180 I'm going to be, right? What's that? 62. So what is that? That should tell me that my reference angle, all right, I'm 62 degrees from being at the reference, or from being at 180. So I get something that looks like this. All right. So it says name the angle in standard position. Okay. Standard position. That is, hold on, I got to find it here. Okay. So what they're looking for is going the other direction. We're looking for the smallest positive angle that'll get me to that point. Okay. All right. Well, that's 180. 180 plus 62. Okay. Why is this? Give me a second here because this is kind of funky. I'll make sure I didn't make a mistake in here somewhere. All right. So 242 degrees is the right answer. I get so frustrated because sometimes I'm like, oh, I did this wrong. I got to start all the way over. You need to unremember everything I taught you, which is really hard to do. So, all right. So 242 degrees is correct. Do we understand what we did there? Right. We get the process. Great. Okay. So let's erase this. We got 242 degrees for that. All right. Now it says which angle is not coterminal with 119 degrees. So we're looking. We're going to go ahead and the first thing we're going to do is actually put 119 degrees on the graph. What quadrant is that going to be in? Second quadrant. Very good. All right, second quadrant. It's going to come out to right there. We know that that is 119 degrees. All right. And we need to check on the rest of these. Okay. So let's look at, I'm going to go probably from the smallest degree. All right. Negative 241. Well, that would be negative 180, right? Let's see. So I would do 241 minus 180, right, to find out how far past 180 I'm going. 61 degrees. Well, if this distance here gets me to that, right, what is the reference angle? If this is 119, we would do 180 minus 119, right? Okay, so that reference angle is 61. So is negative 241 coterminal? Yeah, that's coterminal. Okay, so we're going to count that one out because we're looking for the one that is not coterminal. 479. So that's going to keep going around the direction that we would go. Okay, so there's 360. Let's take 479 and subtract 360 and find out how many degrees I'm going to keep going. 119. Well, that should get me to the same spot, right? Okay, so we know it's not that one. Negative 601. This is where things begin to get like really wild because I'm drawing everything on the same stuff. Negative 601. So I'm going to be going around this way. Okay, I'm at 360. Okay, so 601 minus 360. How much do I have left? 241. And could we tell that's going to do the same thing as that 241 does, just in the opposite direction? Actually, in the same direction, right? Because that was a negative 241. I'm going to keep going negative 241 degrees around. So 601 is coterminal. Or sorry, negative 601 is coterminal. 299 is the only one that's left. But it makes sense that it's not going to work because it's going to go past 119, but it's not even going to get all the way around to keep going to get back where I want to be. So do we understand why 299 is non-coterminal? I could have started there and we wouldn't have gone into the rest of them, but then you really wouldn't understand why the rest of them work. Does that make sense? Okay. So hopefully we understand coterminal. I think that that's probably something that we've looked at in previous math classes, but as a good refreshment on that. All right, let's see. I'm going to go ahead and take this. I'm going to go over to another page so I can kind of blow it up, expand it, write a little bit more. So you guys are looking at this. All right. All right, we've got cosine 2 pi over 3 minus tangent 3 pi over 4 plus sine pi over 3. Now, it's a lot easier, I think, to go from radians back into degrees than it is to go from degrees back into radians, because all I have to do to get from radians to degrees is substitute 180 in for pi. Right, so 2 pi over 3 is just 2 times 180, which is 360. 360 divided by 3 is 120, but I've been doing this a while, right? So cosine 100 and, what did I say, 20 degrees? Okay, minus tangent, right, that's 3 times 180. I don't have that one off the top of my head. 3 times 180 divided by 4, probably around like 135 degrees. I also have it written on my paper, but I do like to make it sound like I know it. And then 180 divided by 3 should be 60, right? That's a little less impressive to do. All right, so for each of these, I'm going to make a coordinate plane. And they're going to start off with these being really nice and easy to work with. They should all come out to reference triangles just in different quadrants. So 120 degrees, right, is going to be 60 degrees shy of 180, which means my reference angle is 60. I got a nice little 30, 60, 90 triangle. This is going to be -1 because of where it's positioned, and it's opposite of 30. I got radical 3. It's positive because I'm above the x-axis, and then 2 right there. Does everybody understand how that works? Right? We could do that, have done that. Great. 135 degrees, right, is 45 degrees off of 180. Right? So I got -1 down here, radical 2. Okay, keeping in mind position. This one's really nice because it just stays right there in that first quadrant. Okay, we got 1, we got radical 3 and 2. Hopefully I've got all that right. So now I'm coming back, I'm looking at the trig function portion of it now. It says cosine, cosine. All of this is going to be based upon the reference angle, right, the one that meets up with the origin. So we're looking for the cosine from 60 degrees. Cosine is obviously adjacent over hypotenuse, so that's giving me -1 over 2. Right? I'm going to bring down this subtraction. Okay, I'm minus tangent. Tangent of 135, so opposite over adjacent, which would be -1, right? Because I'm getting 1 over -1. Right? So I'm going to subtract 1 plus, question? Okay. And then sine of 60, so that's opposite over hypotenuse, right? So I'm getting radical 3 over 2. At this point, you could make this positive, and even easier would be to make it what? 2 over 2, right? Yeah? Do we understand? I'm getting some squinty faces. Do we understand why I did that? Gets me a common denominator of 2. So I can add all those fractions across. It's equivalent to 1. All right, so -1 plus 2 is 1, right? So I'm getting 1 plus radical 3 over 2. Let's see. And you could split that. You could say 1/2 plus radical 3 over 2. Okay, but it's going to be the same thing as this. Questions? No? Okay. Let's see. Do you guys want to work out another one of those, or do you want to move on? Move on? Okay. Just so that you're aware, the answer to number 4, so that if you worked it out, you should get 3 radical 3 minus radical 2 over 2. Let's see if I can find which one that is. I think it's C. 3 radical 3 minus radical 2 all over 2. So C is your answer on number 4. If you want to go back and practice and see, do I actually know how to do this? Okay. All right. Number 5. Number 5. All right. So let me give you the formula first for boat in the water. This will work for a lot of different things besides just boats, but it has to do with anything that has any kind of current to it. So wind or water, things of that nature that have a resistance that pushes one way but helps the other direction. Does that make sense? Okay. No? Does it make any sense to you, Geneva? Okay. Do you understand how current works? Like, have you ever stood in a river or a stream? All right. So with a stream or a river, if I'm going with the flow, that current is pushing me, right? Okay. But if I'm going the other direction against it, what's that water doing to me? It's pushing against me. It's making it harder for me to go. Does that make sense? Okay, so if I have a boat in the water and I'm going one direction, the water is assisting me. If I'm going the opposite direction, it's actually pushing against me. Do you follow me? And wind does that same thing on airplanes. Okay? So, downstream. Okay, this is the equation for dealing with something that's downstream. Keep in mind that wind is also part of this possibility. So we have downstream and upstream. Okay, equations. Now, If you don't understand what upstream is doing and what downstream is doing, this is going to seem backwards to you. But if I'm going downstream, what is the water doing? Is it helping me or hurting me? Helping me. So whatever the speed of my boat is, I'm going to add to it the speed of the water. Okay, it's helping me. Now, that can seem backwards when you look at the word downstream. You would think minus, right? Upstream plus. Don't do that. You need to consider what is actually happening. Okay, you follow me? All right, times time equals distance. Okay, that's the equation. Now, the only difference between downstream and upstream is what the water does. Okay, over here it's B minus W times time equals distance. Now, one of these equations in any given scenario is going to be a T plus. Okay? All right, so let's read the first one. A plane flies 900 miles with a tailwind. All right, let's just stop right there. Which equation am I working with if I say a tailwind? Am I downstream or upstream? A tailwind means that the wind is pushing the plane. A headwind means that it's in my face. Okay, it's pushing against me. If you've ever run in track, you know you got behind you, you got the wind at your back. Is much better than having the wind in your face. Follow? Okay, great. All right, so let's just take the information they gave me. They said a plane flies 900 miles with a tailwind. Where does that 900 go? D, right? On the downstream equation. So this equals 900. Okay, we'll take this one piece at a time because it'll match with all of these other ones, 6, 7, 8, are all going to be the same thing, just with little changes. All right, a plane flies 900 miles with a tailwind in 3 hours. Okay, 3 hours. Where do I put that? All right, so I got 3. Okay, all right. It takes the same plane 5 hours to fly the same 900 miles when flying against the wind. Okay, so what's the distance for upstream? 900, right? He's flying the same distance. Okay, but it takes him 5 hours to do it this time. What I'm going to do is I'm going to stop here. You do need to know this equation, but you don't necessarily have to plug it into all of this in order to figure this out. Okay, what is the plane's speed in air? What I can do is rate, speed, as it is distance over time, right? So I can find out how fast I'm going here, correct? All right, 900 divided by 3. How fast is he going here? 300 miles per hour. Okay? Over here, how fast is he going if it takes him 5 hours to go 900 miles? 180 miles per hour, because the wind is in his face. Now, if I want to find out how fast he's going to go in still air, I'm going to add the 2 up and divide by 2. It's the average, because one is pushing and one is pulling. Okay? So 300 plus 180 divided by 2. This won't work for every single equation, but it works for some of these where you don't have a whole bunch of other information to work with. So that's 480 divided by 2. So how fast would he go in still air? He'd go 240 miles per hour. Okay, does that make some sense for that? Okay, so I'm going to erase this part, but I'm going to leave the upstream-downstream equation because I think that you guys could probably do something like that in your sleep. Right? No? Geneva says no, she doesn't do math in her sleep. Well, no, it doesn't mean that the tailwind is going 60 miles per hour. It means that it's affecting his speed by about that much. I mean, it's possible. I'd have to think about that. Yeah, I mean, because you're getting 60 miles resistance in your face, it's slowing him down by 60 miles per hour. All right, I'm going to erase this. Let's look at the next question. Next question reads like this, and this is one that actually uses the equation. So it says a speedboat could travel 6 times the speed of the current. Okay, so what we're going to do first is we're going to change this. So 6 times the speed of the current means if the current is W, then the boat is 6W. Okay? And that's the same 6W in both equations. Okay? No matter which direction he's going, we know that the speed of the boat is 6 times the speed of the current. Do you follow that? All right? So I'm going to go ahead and finish off the inside and get those two things. Okay? That's not going to be too hard because all I have to do is combine like terms to begin manipulating that inside part. Now the next side, it says, thus it could travel 350 miles downriver. Right? 350 downstream is my distance, right? Okay, it could travel 350 miles downriver in 1 hour more than. All right, so how does that affect? Where does that 1 hour more than go, and how does it go? We're still talking about downstream, right? It could go 350 miles in 1 hour more than. It's going to go with downstream, but what am I going to write here? 1 hour if it t plus 1. Because we don't know how long it's taken, so I can't say, 4 hours plus 1. It's just whatever time it was, it took 1 hour more. Is that, everybody's okay with this so far? Okay? All right. 1 hour more than it took to travel 225 miles upriver. So what goes over here on this side? How can I finish this out? T equals 225. Okay? Now we begin to work both equations. All right, 6W plus W, what is that? 7W, okay, T plus 1 equals 350. Okay, fine. 6W minus W. 5W times T equals 225. Which one's going to be easier to reduce down the quickest, do you think? Probably 5WT equals 225. All right, so that's just really, it's 5WT equals 225. Could I solve for WT? Yeah, by doing what? Dividing by 5. Okay, so WT, okay, that's the speed of the water times time equals what? 45, okay, equals 45 miles. So whatever the speed of the current is times whatever time I'm getting is giving me a distance. Because remember, distance equals rate times time. My rate there is the W. Okay? Now, let's come over here. I can't do anything more with that. But over here, I'm distributing. I'm distributing T plus 1. So what do I get?
7WT
plus 7W. Okay, equals 350. Okay, well I've got this 7WT and I know what WT equals, right? What can I do? Okay, substitute. So 7 times 45 plus 7W equals 350. Okay, what's 7 times 45? 315. So I got 315 plus 7W equals 350. You can tell, like, this isn't hard math. It looks like a ton of work, but have we done anything yet that's I wouldn't have thought to do? Right? There's really no tricky, well, in this particular case, you inverse this, and then you, no. It's just solve the equation. All right, what do I do now? Subtract 315. Okay, so I'm getting 7W equals... All right, what am I getting there though? 35. 35 divided by 7. W equals 5. Okay. All right, so that means that the speed of the current of the water is 5 miles per hour. But what do I need to do in order to find the speed of the boat? Plug it in to basically this or this, right? 6 times the speed of the water is the speed of the boat. So the boat is going how fast? What? Oh, it's 30. 6 times, the boat is going 6 times the speed of the water. So 6 times 5 is 30. All right, 30. Okay. Do we understand this a little bit? Kind of, sort of? Okay, the rest of these all work out pretty much the same in a sense. I'll go ahead. Number eight is the exact same thing as number 5, so it's not really a huge help to you. But I'll tell you that number 7 also comes out to 30 miles per hour. So if you wanted to work out number 7, you could, and you would know what the answer was. Okay, any questions at this point? Sorry, we do have a couple minutes, so I'm going to hit stop on the video, and if you have a question from the review, I'll try to cover at least one of those.